Hello viewers, welcome to the Bachelor's course of Population Studies. Today we will discuss the topic Population Data Collection and Analysis. Collection of data is an important step in research. There are many ways in which the data of population can be collected. One method is census method, which is a very popular method of population data collection. Population data collection is generally done with census method all over the world. The modern population census has been defined by the United Nations as the total process of collecting, compiling and publishing demographic, economic and social data pertaining at a specified time or times to all persons of a defined territory. In simple words, enumeration of the entire population of a country or a region at a particular time is called a census. Periodicity is an important characteristic of a census. That is, counting is done at a regular interval, say in case of India after 10 years. Another characteristic feature of census is simultaneity, which implies that the entire population is counted simultaneously at a specified point of time. Suitability of census method. Where are census method suitable? Census method is suitable generally in the cases where the universe is not vast, where there is a sufficient time to collect the vast data, where finances are not a problem, where the high degree of accuracy is required. There are many advantages of census method. Number one, higher degree of accuracy. No other method is as accurate as census method when the universe is small. There would be higher degree of accuracy in the results using this method. Number two, it's an intensive study. Census method gives opportunity to the investigator to have an intensive study about the subject or the problem. It's suitable for heterogeneous units. The method is also applicable for units having heterogeneity. The method is very important and suitable for data collection in some cases. Without this method, the study of universe remains incomplete. There are certain disadvantages of this method. It's a very perplex method and takes more time in data collection. Because of wider coverage, the method becomes quite expensive and time consuming. It's not suitable for the studies with limited financial resources. The second method is vital statistics. The data on vital events such as births, deaths, marriages, adoptions and abortions, etc. are known as vital statistics. These continuous recordings of such data are known as vital registration system or civil registration system. The first civil registration system was introduced in England and Wales in 1836 and Scotland in 1854. Along with vital events, vital statistics also provide several other ancillary information like sex of the baby, mother's age, the number of previous children, residence, etc. Vital statistics are marked with a great amount of inaccuracy in the larger part of the world, including India. Demographic sample surveys. In a sample survey, information is collected only from a sample of the population which is representative of the whole and from which conclusions are drawn by the use of scientific methods. In a country like Afghanistan, where no census was conducted, population data were collected through sample surveys and some estimates were made of its size, growth, structure and characteristics. Even in countries where regular census operations are conducted, the need for collection of population data through sample survey is felt. For a census is taken in most countries only once in 10 years. The collection of data through sample surveys has several advantages. In the first place, with the help of specially trained interviewers and carefully prepared questionnaires, some special aspects of the population can be studied in depth. The quality of data obtained through a sample survey is better than the obtained from a census because they are collected by a comparatively small number of well-trained interviewers. Despite these advantages, however, sample surveys can never take place either of a census or of vital registrations. Population registers. Some countries like Austria, Denmark, Finland, Israel, and Japan, etc., have removed the need of decennial census by adopting a system whereby population statistics are continuously updated based on information recording in the administrative registers. Each person is assigned a unique identifying number which enables information across different registers, that is birth, death, marriage, etc., to be linked and for central records to be updated. The linking of records means that as well as providing population statistics, the registers can also be used for longitudinal data which follows an individual across the life course. The basic data recorded by population registers are births, deaths, marriages, nationality, migration, etc. Population registers may also cover family relationships, that is, parents, spouses, and dwellings, allowing data on individuals to be linked by family and household. Some Nordic countries also include information on health, educational attainment, employment, and income within the population registers. Let's come on the analysis part now. Analyzing information involves examining it in ways that reveal the relationships, patterns, trends, etc. that can be found within it. That may mean subjecting it to statistical operations that can tell you not only what kind of relationship seems to exist among variables, but also to what level you can trust the answers you are getting. It may mean comparing your information to that from other groups to help draw some conclusions from the data. The point in terms of your evaluation is to get an accurate assessment in order to have better understanding of your work and its effects on those you are concerned with, or in order to better understand the overall situation. Let's see the types of data. Quantitative data refers to the information that is collected as or can be translated into numbers, which can then be displayed, analyzed mathematically. Qualitative data are collected as description, anecdotes, opinions, quotes, interpretations, and are generally either not able to be reduced to numbers or are considered more valuable if left as narratives only. Quantitative and qualitative information needs to be analyzed differently. Broadly, we have 4 types of data analysis. When you begin a data analysis project, you typically begin by analyzing each variable independently to describe the data you have and assess its quality. The next step is then to explore the relationships that exist amongst the variables. These relationships might lead you to draw certain inferences or conclusions about the population the data represents. The conclusions might lead to a mathematical model that predicts the results for data that's not currently in our data set. No data analysis is effective until it leads to a decision or action step. Broadly, there are 4 types of data analysis. Number 1, descriptive analysis. The simplest form of data analysis is this. Descriptive analysis lists and summarizes the value of each variable in a data set. Second type is exploratory analysis. Once you understand the data you have, the next step is to start looking for relationships among data elements. This is called exploratory data analysis and typically focuses on correlations among variables. For example, one data set shows an extremely high correlation between number of cavities a child has and the size of her vocabulary. The third type of analysis is inferential analysis. It's concerned with the various tests of significance for testing hypotheses in order to determine with what validity data can be said to indicate some conclusions. It is mainly on the basis of inferential analysis that the task of interpretation is performed. Fourth type of analysis is predictive analysis, which is very popular in business intelligence applications. The objective is to use data you have to predict an unknown outcome and then to take action based on that prediction. For example, insurance companies use data such as gender, age, marital status, and credit score to predict which customers are most likely to have an accident. Then they increase insurance rates for customers who fall in the high risk groups. Analysts develop predictive models by training the model on a portion of the data set where the outcome is known and then applying the model to the remaining data where the outcome is unknown. Now, we'll discuss the important statistical measures used for the analysis of research data. The 5 important statistical measures used for the analysis of research data are given on the screen. These are measures of central tendency, measures of dispersion, measures of skewness, measures of relationship, and some other measures. Let's discuss these one by one. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. As such, measures of central tendency are sometimes called measures of central location. Mean, median, mode are all valid measures of central tendency. But under different conditions, some measures become more appropriate for use than others. In the following sections, we'll look at the mean, mode, and median and learn how to calculate them and under what conditions they are most appropriate to be used. Mean or arithmetic mean is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data, although its use is most often with continuous data. The mean is equal to the sum of all the values in the data set divided by the number of values in the data set. So, if we have n values in a data set and these are x1, x2 up to xn, the sample mean is usually denoted by and pronounced as x bar. The formula is usually written in slightly different manner using the Greek capital letter sigma, that is, which means the sum of. One of the important properties of mean is that it minimizes error in the prediction of any one value in your data set. An important property of mean is that it includes every value in the data set as a part of its calculation. In addition, it is the only measure of central tendency where the sum of the deviations of each value from the mean is always 0. It has some disadvantages also. It is unduly affected by extreme items, that is the outliers. Another time when we usually prefer the median over mean is when our data is skewed. The second method is median. Median is the middle score for a set of data that has been arranged in order of magnitude. It's less affected by outliers and skewed data. In order to calculate the median, suppose we have the data as shown on the screen. Here we first need to rearrange the data in order of magnitude, that is either in ascending or in descending order. Here we have arranged the data in ascending order. Our median mark in this case is 56, highlighted in bold on the screen. Median also has some disadvantages. It's a positional average. It is used only in the context of qualitative phenomena. It is useful where items need to be assigned relative importance and weights. It is not frequently used in sampling techniques. Then the third measure of central tendency is mode. Mode is the most frequent score in our data set. On a histogram, it represents the highest bar in the bar chart or histogram. You can therefore sometimes consider the mode as being the most popular option. An example of mode is presented on the screen. Normally, the mode is used for categorical data where we wish to know the most popular or the most common category. In this example, we can see that the most common form of transport in this particular data set is the bus. However, one of the problems with the mode is that it is not unique. So it leaves us with the problems when we have two or more values that share the highest frequency. In such case, we use the formula for bimodal series. Mode has certain disadvantages. The problem with the mode is that it will not provide us with a very good measure of central tendency when the most common mark is far away from the rest of the data in the data set. It's not amenable to algebraic treatment and sometimes remains indeterminate when we have two or more modal values in a series. It's considered unsuitable in cases where we want to give relative importance to items under consideration. Then there are measures of dispersion. The dispersion is the tendency of the data to be scattered over a range. It is the important feature of a frequency distribution. It is also called spread or variation. Range, variance, standard deviation are all measures of dispersion. Common measures of dispersion also include interquartile range, quartile deviation, mean deviation. Dispersion measures how the various elements behave with regards to some sort of central tendency, usually the mean. The main measures of dispersion are range, interquartile range, mean absolute deviation, variance, standard deviation, coefficient of variation. We'll discuss these one by one. Range is the difference between the largest and the smallest values. For example, if the lowest and the highest marks scored in a test are 15 and 95, the range would be 95 minus 15, that is 80. Even the range is the easy measure of dispersion to calculate. It's not considered a good measure. It does not utilize the other information related to the spread. Interquartile range is a measure of dispersion which is not affected by the outliers, but nevertheless conveys the idea of range. It measures the spread of the middle 50% of an ordered data set. In other words, it's the numerical difference between the first and the third quartiles. Interquartile range is Q3 minus Q1. Then we have mean absolute deviation. This measure of dispersion is the average of absolute deviations of data values from the mean. It is computed using the formula shown on the screen, where X is the arithmetic mean of the data set. Then we have variance and standard deviation. Variance, as the name suggests, is a measure of how different the elements in a given population are. It's used to indicate how spread out these elements are from mean of the population. There are two kinds of variance, population variance and sample variance. Population variance is the variance of the entire population and is denoted by S2, while sample variance is the variance of a sample space of the population and it is denoted by capital S2. Standard deviation is the square root of variance. It's a measure of how precise the mean of population or sample is. It's used to indicate trends in these elements in a given data set with respect to mean. Standard deviation is simply the square root of variance, so we can calculate it by taking the square root of the above variance formula. Population standard deviation, where mu is the population mean. Types of dispersion. For the study of dispersion, we need some measures which show whether the dispersion is small or large. There are two types of measures of dispersion. One is absolute measure of dispersion and the other one is relative measure of dispersion. Absolute dispersion is the actual variation as determined from the standard deviation or other measures of dispersion. Absolute measure of dispersions are presented in the same unit as the unit of distribution. They can be used for comparison of dispersion in two or more than two sets of data. The absolute measures which are commonly used are the range, quartile deviation, mean deviation, standard deviation and variance, which we have already discussed. Relative measures of dispersion is useful in comparing two sets of data which have different units of measurement. Relative dispersion is the ratio of absolute dispersion to the average. The relative measures of dispersions are coefficient of dispersion, coefficient of quartile deviation, coefficient of mean deviation, coefficient of standard deviation, coefficient of variation, and these are the coefficients only. Then comes the measures of skewness. The first thing we usually notice about a distribution is its shape, whether it has one mode or more than one. If it is unimodal, that is, it has just one peak, like most data sets, the next thing we notice is whether it is symmetric or skewed to one side. If the bulk of the data is at the left or at the right tail, we say that the distribution is skewed right or positively skewed. If the peak is towards the right and the left tail is longer, we say that the distribution is skewed left or it is negatively skewed. We can see it on the screen. The first one is moderately skewed left, the left tail is longer and the most of the distribution is at the right. By contrast, the second distribution is moderately skewed right, its right tail is longer and most of the distribution is at the left. Measures of skewness includes Karl-Pearson's coefficient of skewness, which is measured as skewness is equal to 3 mean minus median divided by standard deviation. If skewness is 0, then the frequency distribution is normal and symmetrical. If it is more than 0, then the frequency distribution is positively skewed. And if it is less than 0, the frequency distribution is negatively skewed. Then comes the measures of relationship. What is a relationship? Correlation coefficients are measures of the degree of relationship between two or more than two variables. When we talk about a relationship, we are talking about the manner in which the variables tend to vary together. For example, if one variable tends to increase at the same time the other variable also increases, we would say that there is a positive relationship between the two variables. If one variable tends to decrease as the other variable increases, we would say that there is a negative relationship between the two variables. Scatter plots and linear relationships can be explained with the help of scatter diagram. A scatter plot represents each set of paired scores on a two-dimensional graph in which the dimensions are defined by the variables. For example, if we wanted to create a scatter plot of our sample of 100 children for the variables of height and weight, we could start by drawing the x and y axis, labeling one height and the other weight, and marking off the scales so that the range on these axes is sufficient to handle the range of scores in our sample. We then continue the process for all of the other children in our sample, which might produce a scatter plot as shown on the screen. It's always a good idea to produce scatter plots for the correlations that we compute. One method to measure correlation is Spearman rank order correlation. It provides an index of the degree of linear relationship between two variables that are both measured on at least an ordinal scale of measurement. The formula for computing this correlation coefficient is given on the screen. The one term in the formula that you might not be familiar with is small d, which is equal to the difference in the ranks of the two variables. Another method is Karl Pearson's, also called product movement correlation coefficient. It is the ratio between the covariance between two variables to the product of their standard deviations. Simple regression analysis. The most commonly used form of regression is linear regression, and the most common type of linear regression is called ordinary least square regression. Linear regression uses the values from an existing data set consisting of measurements of the values of two variables, variable x and variable y, to develop a model that is useful for predicting the value of the dependent variable y for the given value of independent variable x. Elements of regression equation. The regression equation analysis is y is equal to a plus bx plus e. Y is the value of dependent variable which is being predicted or explained. A or alpha is a constant, equals the value of y when the value of x is 0. B or beta is the coefficient of x, the slope of the regression line. It tells us how much y changes for each 1 unit change in x. X is the value of independent variable, what is predicting or explaining the value of y. E is the error term, the error in predicting the value of y given the value of x. There are some other measures of analysis also, and these measures are association in case of attributes, that is the qualitative data. Then there are index numbers and time series analysis. Finally, we can conclude that viewers, you have learnt various methods of population data collection and analysis. Depending upon the type of population to be analyzed and the requirements of research, we may choose any of the above discussed methods of data analysis. The simple method of the analysis are the averages, dispersions, and measures of relationship. When more than two variables are involved, we may use multiple correlations or regression analysis. Analysis is an important phase of research on which the interpretation of results depends. And finally, predictions are made. Therefore, data collection and analysis should be done with utmost care by the researcher. That's all with today's lecture. I hope that the lecture has given you clarity about the subject and has added to your knowledge. Next time, we'll discuss another important topic. Till then, have a nice time. Bye-bye.